In this video, we'll be learning how to solve multi-step logarithmic equations. So it's a log equation that might have extra steps, add, subtract, multiply, divide, outside or inside that logarithm. So the process that I use to solve these on the right here is isolate the logarithm. That just means get the log by itself. The argument on the inside we can leave alone, but we're trying to get it down to one logarithm. And then we'll convert to exponential form, and then we'll solve for x whatever is left over. So on this first one, we have 3 log base 2 of 2x equals 15. Now the 2x is inside this logarithm. Oops. And so we're just trying to get the log base 2 of 2x by itself. So the only thing that's not inside the log is that 3. So I'm going to go and get rid of the 3 first. I'm going to isolate that log. So we're going to divide both sides by 3 to get the log all by itself. So these 3's cancel. I get log base 2 of 2x equals 15 divided by 3 is 5. And now I've done the first step. I've isolated the log. Now once I've done that, I can convert that to exponential form. So remember to convert, you always start with the base. So the base on this one is 2. So we're going to take 2, raise it to the 5th power, and it's going to equal the argument or whatever's inside that log. So it'll equal a 2x like so. And then the third step, solve for x, whatever you have to do that's left over. So 2 to the 5th is 32. Equals 2x, and then we can divide both sides by 2. So it looks like 16 equals x. In this next example, we have a couple extra steps. We have something inside the log, an x plus 1. We'll deal with that at the end, but we also have a 15 plus 2 on the outside. So we want to get rid of that stuff first. We want to isolate the log by itself. So I'm trying to get this log part all by itself first. So I got to get rid of the 15, and I have to get rid of the 2. So when we're solving for x, or solving any equation for x, we want to work backwards on PEMDAS. So any addition or subtraction you can do first, go for it. So the 15, I'm going to go ahead and subtract 15 on both sides. So we'll go ahead and take 15 off on both sides, and we're left with 2 log base 2 of x plus 1 equals 6. And then I'm going to get rid of that 2, just like on the last problem. So we're going to divide both sides by 2. So I'll divide this side by 2 and this side by 2. That gives me log base 2 of x plus 1 equals 3. So that's the first step there, is to isolate the logarithm. Now we're going to convert that to exponents. So we start with the base. Base once again is 2, so it'll be 2 raised to the 3rd power, and that'll equal whatever is on the inside. So on the inside there, it looks like is our x plus 1. The third step there, solve for x, whatever you have to do. 2 to the 3rd is 8, so I'll simplify that. Equals x plus 1. And then I'll just subtract 1 from both sides. So it looks like I get 7 equals x. In this next example, we have multiple logarithms, so we still want to isolate the log. We still want to try to get one logarithm by itself. Since I have 2, I can condense those, or I can combine those into one logarithm. So from a previous video, we learned that if we're adding logs together, we end up multiplying the arguments, or multiplying what's on the inside. So I'm going to condense these into one logarithm. It'll be log base 6, and then I'll multiply the 5x and the 3. So the 5x and 3 get multiplied inside of one logarithm. So I condensed it into one logarithm, and I've gotten that log all by itself. So once I've done that, I can convert that log to exponents for step number 2. So I'll start with the base. The base on this one is 6, raised to the 2nd power, and then equals all the stuff on the inside. Well, 5x and 3, that would be 15x. And then I just solve for x however I have to solve for that. So 6 squared is 36 equals 15x. And then I'll divide both sides by 15. I could just leave it as 36 over 15, or I could throw that on my calculator and see what I get. So 36 over 15, we'll just look over here. 36 over 15 is 2.4. So 2.4 equals x. In this example, I still have a couple logarithms, so I want to condense those together, and then I'll solve from there. So always try to get it down to one logarithm if you can. So I'm adding these logs together, and so to condense these, I would multiply the 2 insides of those logs. So this would give me log base 5 of x squared minus 3 multiplied by 2, and so I'll have to distribute that 2 equals 0. Now, I've condensed it, so I've got the log by itself, and I can convert it from here. So I'm going to convert this to exponential form. So the base is 5 raised to the 0 power equals all of that stuff on the inside. Now I'm going to distribute that 2 in there. This would give me 2x squared minus 6. And then I'll solve this equation for x. So 5 to the 0, anything to the 0 power is 1, equals 2x squared minus 6. And then to solve for this x, I would add 6 on both sides. And so I get 7 equals 2x squared. Oops. And I would divide both sides by 2. And I'll finish that up here. So 7 over 2 equals x squared. And then I'll square root both sides to get that answer. So I'll square root this and that. So I get plus or minus whatever 7 over 2 square rooted is, this will equal x. So I can put that on my calculator. Let's see what I get there. So I get the square root of 7 divided by 2. And so it looks like 1.87. In this last example, I do have a couple logarithms on one side and I have a logarithm on the right. So I have several options here, but I am just going to condense the logarithms on the left side and just see what happens here. So let's go ahead and condense these two logarithms. So it's log base 4. Since I'm subtracting these two logarithms, I'm going to divide their arguments, their inside. So it'll be 26 and then divided by x plus 10 equals log base 4 of 2. From here we have a couple options as well, but I think the easiest way to think about this is we have two logarithms, and so their arguments or their insides would have to be equal. That means that this inside log has to equal this inside log. So I'm going to shortcut that a little bit, and I have two equivalent logs. That means their insides would have to be equal. So I'm just going to jump to that. I'm going to say 26 over x plus 10 equals 2. So I've got the log by itself. I converted it. I didn't do either of those things, of course. In this example, I actually have 3 logarithms, so I have several options here, but I'm going to do kind of like what I did in the last examples, where I want to condense the left side. I want to get that down to 1 logarithm if I can, and normally I'd say convert this to exponents, but we're gonna shortcut that step just a little bit. So we're gonna condense these two logarithms together. If we're subtracting logs, we divide the arguments or the inside. So we're going to divide those inside pieces. So we're going to take log base 4. And we're going to divide 26 and x plus 10. And then that will just equal log base 4 of 2. Now, normally I'd say convert to exponents. I'd take the base, raise it to the power, but this one actually is a little bit easier than that. Since I have two equivalent logs on both sides, that means their arguments or their insides have to be equal to each other. So I'm going to throw a parentheses just to help us see this better, that inside, 26 over x plus 10, has to equal this inside, or 2. So since the logs are the same, their insides would also have to be the same. So I'm just going to set the insides equal to each other. So I'll say 26 over x plus 10 equals 2. So I've basically gotten rid of the log, not by converting, but just by setting the insides equal to each other. So now I just solve for x, however I have to do that. So let's get rid of that pesky fraction. Let's multiply both sides by that denominator. So I'm going to multiply both sides by x plus 10. That will cancel this fraction out. And so all I have left on the left side is 26. So 26 will equal 2x plus 10. So we'll distribute the 2 in there. And so that gives me 2x plus 20. And then I'm going to solve that one for x. So we'll subtract 20 on both sides. So subtract 20. So I get 6 equals 2x. And divide both sides by 2. So I get 3 equals x. So x would equal 3 on this one. And this one we can check our answer pretty easily. But if I plugged a 3 back into the original equation, back for that x right there, I would have log base 4 of 26 minus log base 4 of 13. And if I divide those two, 26 and 13, divided is 2. So that verifies that that is my answer.